In this video, I wanted to talk briefly about safety. If you're going to take apart a piece of electronics and try and repair it or mod it, then you need to be very careful because there can be dangers inside of it. So for an example here, this is a TV that I recently repaired, and so we'll go ahead and use this to demonstrate some of the different safety hazards inside of a television set. And this will be true for any LCD television or computer monitor, which is an item that's very common and a lot of them fail, and they're pretty easy to repair. So it's a very common thing that a beginner might want to try and repair. And so I'll talk about there are 3 different hazards in here that a beginner needs to be aware of. So the first hazard to be aware of is the inverter for the backlights. Now, televisions and monitors up through probably around 2010 or so, they used what are called CCFLs, cold cathode fluorescent lights, as the backlighting. And so there's basically tiny little fluorescent bulbs that run across the back of the TV set to light it up. Newer TVs, they use LEDs as the light source, and so you won't find this. But if you're repairing a TV, chances are it's going to have these CCFLs in it, and these use high voltage. So this here, these are rows of transformers, and these are step-up transformers. And the output voltage on these, so on the light bulb side here, this is this primary side, this is the secondary. The step-up side here comes up to in excess of 1,000 volts. So you definitely do not want to get your hands anywhere in here. I should comment the TV is unplugged right now, and when it's unplugged and turned off, it's safe in this area. You don't have to worry about anything. But if the TV is plugged in and turned on, there is upwards of 1,000 volts along here. So you definitely don't want to touch or get your hand anywhere near here. Don't want to get tools near here like a screwdriver. And you don't even want to get your probes like on your multimeter around here, because most multimeters cannot handle in excess of 1,000 volts. It will blow the inside of your multimeter. So this is definitely a hazard area. Now, not all televisions are going to look like this. Some of them you may only have 1 or 2 transformers. They don't all have a row of transformers like this. This one is an array of tubes across the back, multiple tubes, and so there's a lot of transformers. But a lot of them, they only have 1 or maybe 2 transformers. So first danger, be careful of the step-up transformers for the backlighting. The second hazard to be aware of is capacitors. Now, all of these circular devices, these are all capacitors, and a capacitor is basically an energy storage device, and any capacitor could have a charge on it, but it's the bigger ones that you need to be aware of. For example, this one right here, I believe it's rated at probably about 400 volts, which means there is potentially 400 volts of electricity on that capacitor. Even if the TV is unplugged and turned off, there can still be 400 volts on there. Now, if the TV is designed properly, when you turn the TV off and unplug it, that voltage discharges off of there, but don't assume that the TV discharged that capacitor. It may still be charged. So I'm actually going to run an experiment here. I'm going to see how much charge is on that capacitor and how fast it discharges afterward. So what I've got set up here is a little experiment. So I've got the 2 leads from my multimeter connected to that capacitor, and I'll go ahead and turn it to DC volts. And the TV is unplugged at current state. So I'm going to plug it in, and then we'll see what happens to the power voltage. And then we'll turn the TV on and see what happens, and then we'll turn the TV off and see how long it takes to discharge. So first I'm going to plug it in. And so 165 volts, and the TV is in standby. It is not turned on right now. So just in standby, 165 volts across that capacitor. So now I'll hit the power button, and we'll see what happens. Up to almost 380 there. Jumping around. Let's see if it settles down. Backlights are on. So it seems to have settled around 252 volts. So it peaked there at almost 380, just under 400 volts. And now let's go ahead and turn it off and see what happens to the voltage. It's off. Still 240. Okay, so there it's dropping. And now it's back down to the 160 that it was before. And now I'm going to unplug it and we'll see how fast it discharges. And it's unplugged. So there it's discharging down. So that was actually pretty quick to discharge down to a low amount. So this particular TV, that discharged in just a few seconds, but do not assume that your TV or your monitor, if you're working on something, will discharge that fastly. They may not discharge at all. So, you know, you can always use your multimeter and test across those probes or those points there carefully to see how much voltage is on there, but that's a definite danger right there. Several hundred volts, up to 400 volts DC across that capacitor. That is very dangerous. And the last hazard that I wanted to talk about that I actually found out the hard way myself, these heat sinks on the power board here, those may be live with respect to ground. That basically means if you touch them, and if you're touching any other part of the frame of the TV, you may get an electrical shock. Now I would have expected all of those heat sinks to be grounded, but they may not be. So what I've actually done, can't see it back here, but I've clipped my ground lead onto the chassis of the TV. I'll go ahead and turn it to volts DC, and the set is unplugged right now, so these should all measure at or at about 0 volts. And indeed they do. So now I'll plug the TV in, but not turn it on. And let's see what we get. 0, 76, 76 again. So it looks like a lot of them are coming up at 76 volts. So that's almost 80 volts difference from the heatsink to the chassis, which would give you a very nasty shock if you rested your hand across there. And the TV is not even on, it's in standby. Let's go ahead and turn it on and see what happens. So TV's on now. Let's wait for the backlights to come on. There we go. And let's see again. Still 0. So negative 52 volts. So now a lot of them are reading 52 volts on there. So it's interesting that it's actually less voltage on there when the TV is on versus off. So definitely that's something to be aware of. Again, I found this out the hard way. I would have expected those to be ground, but you know, if you just rest your hand across there, you may get a shock. So be aware that heat sinks may have voltage on them. So hopefully that was a learning experience for you, and you learned a little bit about safety if you're thinking about taking a TV or monitor apart and trying to repair it. Thanks for watching.